Next, let's go to page 784, where we consider the properties of determinants. There's a bunch of properties here. Let's go through each one. Now, the first property says if the matrix is in the upper triangular form, that just means that upper triangular means that below the diagonal is everything 0. On top of diagonal, it can be whatever. If that is the case, then the determinant will be equal to the entries down the main diagonal. That is, the determinant of this matrix, regardless of what's up here, is going to be equal to 1 times 2 times 3, which is the numbers going down the diagonal. And this is true for a matrix of any size. Okay, this is a 3 by 3, but well, determinants are only defined for square matrices anyway, but I'm just saying that if it was a bigger or smaller matrix, this plan goes. That's assuming everything is 0 below the diagonal. And whatever is on the diagonal and up, we don't care. Okay, as long as everything's 0 below the diagonal, then the determinant will be calculated by this times that, and that's it. So that's the first rule. The second rule says when the two rows are interchanged, the determinant changes sign. So if we were to flip these two rows around, so this one goes on top and that one goes on the bottom, then the determinant has to you have to slap a negative on the result of the original determinant. That is, if you use the original determinant and just slap a negative sign on it, it will be the answer to the new determinant. That's if you change two rows. Next, if two rows or two columns are identical, then the determinant will be 0. Okay, so if any two rows or two columns then are the same for some reason, then the determinant is automatically 0. Number 4, if a matrix contains a row of zeros or a column of zeros, then the determinant equals to 0. Yeah, it cannot be all 0 in any row or column, because then when you calculate the determinant, you will be hitting a 0 every time you multiply, so everything will be 0. And number 5, the determinant of an inverse matrix is the reciprocal of the determinant of the original matrix. So if you do manage to calculate the inverse after a big, long, tedious process, then its determinant is the determinant of the original matrix except 1 over it. So if the original matrix determinant is 5, then the inverse matrix will be 1 over 5, that sort of thing. And then if any row or constant or column is multiplied by a constant, then the determinant is also multiplied by the same factor. All right, so that is, if we multiply, say, this last row so that all the numbers doubled here, just the last column, or any row, doesn't really matter, then suddenly the determinant also changed. Okay, by multiplying by the same amount. So let's look at example 7 on the same page, which demonstrates the properties that we just mentioned. First, let's say property 1 says that, let's look at the example. Property 1, which says that if things are 0 below the diagonal, okay, then the determinant is simply the diagonal multiplying together. That's it. You don't have to worry about anything else. The reason is because when you repeat the first two rows, you got 2 zeros at the bottom, which means when you follow the rule to calculate determinant, you do that crisscross thing, okay, and then you hit 0 except for the diagonal. So please do this yourself, okay, to make sure that this is true. This is example 7, and please confirm this thing yourself. Okay, and property 2 says if you interchange rows of a matrix, then you change the sign of the determinant. So as an example here, please do this yourself as well. There are two matrices. The only difference is their sign, their rows got interchanged. So calculate the determinant of each to see what the difference is. Let's see. Yeah, see, one is negative 17 and one is just 17. Next, property 3 says that if two rows or two columns are identical, then a determinant is automatically 0. And well, anyway, so here's a sample. And so please calculate the determinant of this thing. See, it has two identical columns. And then you calculate it and realize the determinant is 0. So please do that yourself. And next, let's look at property 4, which says that if a row or column is 0, the determinant is 0. That's the most obvious one, okay? Because the determinant is you have to do that cross multiplying, and you're multiplying by zeros all the time. So everything, it just falls apart and becomes 0. So that property 5, next property 5 says if you have an inverse matrix, and then its determinant is the reciprocal, that is 1 over. And as an example of that, so please do this also. There's a matrix here, okay? Calculate its determinant. This is its inverse. Calculate its determinant. And you notice that one is the reciprocal, that is 1 over. Okay, the other, that is this determinant is -2. Then this one is -1/2. And then finally, the property 6 says if any row or column is multiplied by a constant, then the determinant is multiplied by the same factor. So there is another sample, and please do this as well. If you if you multiply some row or column by a fixed number, then come to find out the determinant is increased by the same amount, is multiplied by the same amount. So that's example 7. So next, let's look at example 8 on the same page, where we are supposed to use the Cramer rule to solve this system. And the system goes like something like this, okay? And if you look at it more carefully, you notice that the equation 3, x plus 2y plus 2z equals to 4, is the same as it's the same as the top equation, where 2x plus 4y plus 4z equal to 2. At least this part is the same, okay? The numbers are different, but this part is the same, which is not possible already, because if this equals to 4, then twice of this had better be 8. There's no way it can be 2. Okay, so this is there is just from that fact alone, there is no solution to this thing. However, what the book wants us to say is let's write down the determinant. The determinant of this system is just all the numbers in front of the variables, right? 244, 377, and the 122 on the bottom. And the book says that you notice that you have two columns that's identical, right? And which, according to property 3 on the previous page, if either two rows or two columns are identical, the determinant equals 0. So we don't have to do any math here. We know the determinant is 0. So that's from property 3. But that's not the only property that says they are the 0. There's also the property, let's see, let me see, I thought, give me a second here. I see that it doesn't have the property I'm thinking of, so let's skip that one. And so as the book says, then according to property 3, if you have two identical rows or columns, in this case there are two identical columns, we don't have to do the math. The determinant is automatically 0, and therefore we cannot use Cramer's rule to figure this system out. And so what we're gonna do is as the book says. See, I already said that the system has no solution, because there's no way this is gonna happen. Okay, if this equal to 4, that had better be 8. There's no way it can be 2 or anything else. And so while we know that, we're gonna perform elimination. That's another way of proving this thing, and we'll do what the book says, okay? And the book says we need to take equation 3 times minus 2. So we'll take equation 3 and multiply it by minus 2 and add it into equation 1. And why are we doing this? See, equation 3, if we multiply it by minus 2 and add it to equation 1, that'll knock out the x. See, there's a 2 there. You multiply it by minus 2 here, and that'll get rid of that. Okay, and so let's do that. So equation 3 times minus 2 added that would be, let's see, Well, give me a second here. What is? Never mind. Anyway, we're going to do that. So this thing times minus 2 plus that would be 0. And we won't write that down. Plus 2 times minus 2 added that is also 0. This again times minus 2 is 4, plus 4 is still 0. So this side is completely 0. And finally, on this side, 4 times minus 2 is minus 8, plus 2 is minus 6. So that doing this operation results 0 equal to minus 6, which is not possible, and therefore this system has no solution. And that is the answer. And the end of this section. Okay, so please do all the examples as part of your homework, as always, and I will find some homework. So for homework, please do problems 7, 21, 33, 39, and 47, and that's it. Yeah, so when you're done, I will talk about some of them. All right, so for let's now do problem 39 of the homework on page 787. I have 4x minus 2y plus 3z equal to 6, minus x plus y, and there's no z, so I wrote down 0 just to remind myself not to forget it. Equals minus 2. I don't know how important that is, but anyway, 2x plus 7y plus 8z equals to 24. So I have the determinant written down here. We're supposed to solve it with Cramer's rule, which means we have to calculate the determinant of this thing. So we have to write down all the numbers here in the matrix. 4, minus 2, 3, minus 6, 1, 0, 2, 7, 8. All right, and then I repeated the first two columns over here. Okay, that's how you calculate the determinant. And so we have 4 minus 6, 2, and minus 2, 1, 7. Okay, so everything looks okay. And then, so let's do that calculation trick. As soon as I find the calculator. All right, I got it. Now remember how to calculate determinant. You do these three numbers. Okay, start with first number, 4 times 1 times 8. And then the second diagonal down, minus 2 times 0 times 2. And then add the third column, third diagonal, 3 times minus 6 times 7. And then subtract going up. Okay, this way, that, and that. Okay, 3 down, 3 subtracting 3 up. So let's do that. Okay, so I will do 4 times 1 times 8, that's 32, okay, plus minus 2 times 0, stop talking, okay, that's all 0. Next, 3 times minus 6 times 7, that is negative 18 times 7, okay, so that's all the going down, the addition stuff. So next, we'll do minus, so minus. First one, 2 times 1 times 3, that's 6. Next, minus 7 times 0, we'll stop right there. Okay, if it's 0, there's nothing to say. And then last one, 8 times minus 6 times minus 2, that's 8 times 12. That's 96. Positive 96. So I type in 96. I already have the minus sign in there, see? And so that is that. So let's see what it says. That doesn't look so great, but oh well. Let's say this is right for the moment. Okay, I will worry about it later. So this is negative 196. Anyway, I wish it was a nicer number, but it's not. And the next thing we need to do is by Cramer's rule, we need to calculate all the other determinants. That is, we need to calculate dx, and then dy and dz. What is dx? Dx is the determinant of the same thing, except that these numbers here will replace the x column. This is the x column. See, those are all the coefficients of x. So we're going to do that. Okay. So the x column will be replaced by 6, and then minus 2 and 24. And then the other two columns will be the same. So I'll write that down. All right, so now we have dx by using this column replacing the x values originally. To calculate dx, we'll do that same thing, okay? We will, so let's do, let's see, I will stand over here. 6 times 1 times 8, that's 48, okay? The first diagonal. Minus 2 times 0, we'll skip that one. 3 times minus 2 times 7, that's minus 42. So I'll put that in. Okay, so that's all the additions. And the next minus 24 times 1 times 3, that's 72. Okay, and the next one is 0. And then the next one, because it's 7 times 0 times whatever, we don't care anymore. And so the last one is 8 times minus 2 times minus 2. That's 8 times 4. That's 32. All right, so that should give us negative 98 to be dx. I will write that down here. So the dx equal to negative 98. So that means x equal to x. From this, we know that x equal to dx divided by d, okay? And we have calculated d to be 196. So that divided by 196 is equal to, divided by 196 is negative 1/2 is what I got. Equals to minus 1/2. And let's check the answers in the book. What is this? 39? Yep, x is indeed minus 1/2. So this checks out. So far so good. Next, let's do the dy. Now dy would be using these 3 numbers and replace it in the y column of numbers, which is the middle one. Okay, so we will write down dy. To calculate dy, then we will write down the first row is the original, and the second row we will write down the 6 minus 2 and 24. And then so I will write down the rest of these things. All right, I have done finished writing dy. Dy is this, the last column of numbers, slapped it on top of the original y coefficients, okay? And then we calculate, the rest stays the same, and we calculate the d. So that's what I did here. And then I repeated the first 2 columns. And then we're going to calculate the determinant, the same trick of going down the diagonal 3 times, then going up the diagonal 3 times. So let's do that. So we have 4 times 2 is minus 2. There's negative 8 times 8. That would be negative 64. And then that's the first diagonal. Next, plus, next is 60. That's 0. And then the last one, 3 times minus 6 times 24. That's negative 18 times 24. So we'll type it in. All right, so that's all the going down the diagonal, all the addition. The going back up is minus. So minus 2 times minus 2 times 3, that's negative 12, right? So I'll type in negative 12. Next, 24 times 0, we'll stop right there. Forget that one. And then the last one, 8 times minus 6 times 6. That is that's a negative 36 times 8, right? Yes, so we'll type that in, negative 36 times 8, and that should be it. I get 200. So dy equals to 2. So the dy equals to minus 200, negative 200, which means y would be equal to the dy divided by d, according to the Cramer's rule, okay? Which is, we'll figure out what that is. That divided by negative 196 equals to, I don't think I got it right. Let me check here. Nah, I got it wrong. Let's try again. Maybe you got it right. So anyway, I'm going to try it again. 6 minus 2, 24. Yeah. I'll try this again and see what happens. Actually, maybe I should check somewhere else. All right, so I tried it again. Now this time, I got the right answer. I wonder what I did. But anyway, we have, yeah, so minus 4 times minus 2 times 8, that's negative 24. And then plus the next one is the 0 one. We skip that one. And then the last one, 3 times negative 6 is minus 18 times 24. And then minus going up, that's negative 12, right? And then the last one is 8 times negative 36. So, and this time it gives me minus 196. I wonder what I did wrong the last time. Who cares? The point is I got the same as this one. So dy is actually negative 196. The same as d, which means that y equals to 1. Okay, negative 196. So y is equal to 1. So so far so good. Now we just have to do the last one with z, which we're going to take this column and slap it on top of the z column. But otherwise, everything would be the same. Let's see, I'll write it down here. So dz equals to this thing will have this thing on the last column. 6 minus 2, 24. 6 minus 2, 24. But everything else will be the same as this stuff. So I'll write that down. So I wrote down the last this number on the last column, over the last column, okay, replace that. But everything else is the same, or at least should be. Yeah, so then now let's calculate the determinant, the dz. Okay, so let's do the same thing again. Now this time we have 4 times 1 times 24, so 4 times 24. Plus, next, we have minus 2 times minus 2, that's 4 times 2 is 8. So next, 6 times minus 6, and negative 36 times 7. All right, so then minus, going back up, 2 times 1 times 6, that's 12, minus. And then the next column up, 7 times negative 8, right? That's negative 56, minus 50, negative 56. So we have a minus negative 56 there, which is fine. Next, the last one to subtract is 24 times 12, right? 24 times positive 12 times 2. Yeah, so I got, what is that? 392. Okay, that might be okay. So I got dz equals to negative 392 minus 392. And so that means, so z equals to dz over dy by Cramer's rule, dy, and dz over d. Where does y come from? Y has nothing to do with it. There. So dz, that is, I think 392 is exactly double of that. So that means z equals to 2. And that is, that should be the answer. Yeah, that is correct. And that's the end of problem 39. All right, so next I want to talk about problem 47, and the reasons because that is going to be a very neat problem. Problem 47, we have a giant matrix, okay, but you notice that all the stuff down here is 0. All the stuff below the diagonal line is 0, right? And there's stuff on top, but it's all 0 here. And one of the properties of the determinant says that if the stuff below the diagonal is all 0, then the determinant is simply multiplying the diagonal all the way down. In other words, the answer is 1/2 times 1/2 times 2 times 2, which is just 1. And if you look at the answer, that is correct. So that is that should be the end of this section.